So, spatial audio over loudspeakers. Let me start by telling you something that might surprise you. Any sound that we as humans can hear is simply a collection of vibrations in the air around us. So imagine yourself being constantly immersed in this gaseous ocean of these vibrations and waves and wiggly things, and you get a sense of how sound is really all around us all the time. And a loudspeaker is simply a device that can create these vibrations in the air by vibrating a membrane back and forth at different speeds, exactly in the same way that our vocal cords do when we speak or sing. If you have just one loudspeaker, you can produce what's called a monophonic or mono sound. The loudspeaker essentially acts much like my mouth. There is just sound coming from one source in this general direction. But then if you add a second loudspeaker, something cool happens. Because by playing with the volume of a single sound or source, as it's played through both of these loudspeakers, you can actually make the source appear to be coming from anywhere in between those two loudspeakers. This is called panning, and it is the most basic way to spatialize a sound in a stereophonic or stereo system. Now, stereo has been the de facto standard in sound and music production over the past many decades, simply because it is the most convenient and affordable way to add some depth and detail to any kind of sound or music you might be listening to over loudspeakers. But of course, we don't need to stick to 2 loudspeakers. We can use 3 or 4 or 64. As you can imagine, increasing the number of loudspeakers allows us to have a finer control over where exactly we place our sources of sound in space. And with a full sphere of loudspeakers like this one, we can put them almost anywhere. Now, advanced spatial loudspeaker arrays like this one use methods that go way beyond the simple panning example I just described. Instead, they use concepts like 3D time-frequency decompositions and spherical harmonic functions. Truly cool and cutting-edge stuff. Most of the time though, spatial loudspeaker systems that we can realistically construct and deploy in the real world are smaller ones, with perhaps 8 to 12 loudspeakers, or the really advanced ones containing maybe 24. But even those systems are now becoming pretty powerful, and that is mainly thanks to large systems like these that are absolutely critical for developing and optimizing the spatialization techniques that are then used in the smaller real-world systems. I will talk more in depth about these different spatialization techniques and how you can actually realize them. But for now, understand that there are a wide range of possibilities for rendering spatial sound over loudspeakers, and that it is important to know and properly select the appropriate one for your specific application.